Hey everyone, welcome to today's Explainer. Today, we're going to figure out how to take those intimidating, messy word problems and transform them into crystal clear visual stories. You know that feeling when you stare at a massive paragraph just packed with numbers, rates, and moving parts, and your brain completely freezes up? Yeah, you're definitely not alone in that. But today, we're unlocking a skill that's going to totally change how you approach math. We're taking those numbers, pulling them right off the page, and giving them a visual form, so you can literally see the solution right in front of you.
Here's our quick roadmap for today. We're covering 1. Seeing the math, 2. The three-step process, 3. Real-world math examples, 4. Your turn to practice, and finally, 5. Wisdom for your life. Let's dive in.
Starting off with Section 1, Seeing the Math.
It's actually really fascinating how this ancient wisdom perfectly describes the whole concept of graphing. The quote says, "Write the vision, make it plain on tablets." Think about it. A word problem is basically a confusing, jumbled vision, right? Well, our job when we graph is to take that confusing paragraph and, you guessed it, make the vision plain. We're quite literally taking a complex situation and making it so incredibly obvious that anyone can understand the relationship in a single glance.
Translating words into visual graphs is honestly a superpower, and not just for school, but for your everyday life. Why? Because a good graph lets you predict results before they even happen. It lets you put two different options side by side and compare them instantly. Say you need to explain a complex budget or a timeline to someone. The graph does all the heavy lifting for you. It really sharpens your ability to model relationships and turns you into a top-tier problem solver.
Moving right along to Section 2, the three-step process.
Okay, this three-step process is basically your secret cheat code for beating any word problem without totally overloading your brain. First, identify your variables. Just figure out what's actually changing. Second, translate those words into a math equation and build a quick table of values to test it out. And third, plot those points, sketch your line, and, please don't forget this part, label your axes and give it a title. A graph without labels is just a random line floating in space. The labels are what give it a story.
The absolutely crucial part here is nailing your X and Y right out of the gate. Let's break it down. In pretty much every real-world scenario you're going to see in 8th grade, your X-axis, that horizontal line across the bottom, is going to represent time. Hours, weeks, minutes, whatever. Time just marches on independently. Now your Y-axis, the vertical one, is what depends on that time. It's the quantity that's changing, like the money in your bank account, the distance you've driven, or the temperature outside. Get your X and Y right, and everything else just falls perfectly into place.
All right, Section 3, Real-World Math Examples.
Let's look at a scenario we literally all panic about, a dying phone battery. This is a brilliant way to see how we translate an everyday sentence into math. Our sentence is, a phone battery drops 20% per hour from 100%. So let's apply the steps. What's X? Time in hours. What's Y? The battery percentage. Because the battery is dropping, our rate is -20. And where do we start? At 100%. So our equation is simply Y equals -20x plus 100. If you sketch that out, you start way up at the top of your y-axis at 0, 100 and draw a steep declining line all the way down.
Now how about a water tank that starts with 50 gallons and drains 5 gallons an hour? A table of values shows exactly where the graph begins and ends. At hour 0, before any time has passed at all, our y is 50. That's our starting point. If we drain 5 gallons every hour, how long until it's completely empty? 10 hours, right? So at x equals 10, our y is 0. By plotting just those two simple points, 0, 50 and 10, 0, and drawing a straight line between them, you've completely mapped out the lifespan of that water tank.
Let's flip to a positive example, making money. Say you earn $10 an hour walking dogs. Your equation is just y equals 10x. There's no starting bonus, so at 0 hours, you have $0. That means your graph is going to show a beautiful, steady increase starting right from the bottom corner, at the origin, 0, 0. For every 1 hour you move to the right on the x-axis, you move up $10 on the y-axis. It really is that simple.
Section 4, Your Turn to Practice. Let's see what you've got. Grab some paper or just visualize this with me. Think about a car traveling 60 miles per hour, which gives us the equation y equals 60x. Now think about saving $5 a week, starting from $0. Ask yourself, are these lines going to go up or down? Well, since distance and savings are both increasing over time, both of these lines are definitely sloping upwards. Just remember to use that three-step process to build your tables first. At week 0, $0, week 1, $5, week 2, $10. You can clearly see the pattern emerging, right?
Next challenge. A candle is 12 inches tall and melts 1 inch per hour. Can you picture the graph? Take a quick second to identify your x as time in hours and your y as the candle's height in inches. Your starting point, your y-intercept, is 12. And since it's melting, that line is going to map out a steady downward slope of -1 right until it hits the x-axis at 12 hours. Okay, final practice scenario. See if you can mentally write and sketch the equation for this one. A movie theater starts with 120 available seats and loses 30 seats per group entering. Try translating that starting amount, the 120, and the loss per group, which is a -30, into your y=, equation before you start plotting. You should end up with y= -30x plus 120. Every single time a group walks in, that line drops by 30 until the theater is totally packed.
Finally, let's zoom out for Section 5, Wisdom for Your Life. The source material from the heroesmartacademy Godly Learner series brings up a pretty thought-provoking concept here. They argue that education without morality will hurt. According to their curriculum, what's the point of being highly educated if you're making choices that end up hurting you or the people around you? It's kind of like a math equation. An equation has rules that dictate exactly where the line ends up. They suggest that the moral choices you make create a similar trajectory for your life. If your equation is packed with negative inputs, your life's graph is ultimately going to slope downward into hurt.
But the series maps out a different future using Romans 8:6-7, which states that keeping your mind spiritual leads to peace. Just like a perfectly drawn graph helps you predict a math result, this curriculum proposes that anchoring your mind in biblical morality helps predict a peaceful life. They argue that when your foundational equation is built on these truths, your ultimate Y value is peace of mind.
So, by learning to graph today, you've essentially learned how to make the vision plain. You can look at a scenario, find the starting point, map out the rate of change, and predict exactly what the outcome will be. But I want to leave you with one final thought to ponder as we wrap up this explainer. When you look at the daily habits you are building right now, what kind of line are they drawing for your tomorrow? Map out your choices carefully and keep your vision plain. Thanks so much for hanging out with us today.